You're back? Good. Let's dive into the block controller side of this. Open up your displays control block controller, and we'll go into our editor window. And as always, we're going to think it through with comments. We're going to debug as we go, right? So think it through with comments. I'm going to grab my comment block. All right, this is pretty simple. When the power button is pressed, okay, we know that's going to translate to an event handler. Let me fix up that space there. Oops, Then what's going to happen? Then we want, if the button is on, turn on the displays and update the label of our button. When the button is off, then turn off the displays and also update the label. Those are our instructions. Okay, so let's grab our event handler for our Power Master. That's the one button we've given them. Our event handler for Power Master is when the power button is pressed, and then we need to, we need an if-then statement. Again, we're getting into familiar territory. Hopefully this is getting in your bones. So flow control, if and else, right? Either it's on or it's off. And if it's on, we can just use its Boolean states like we talked about the last time. I can just go to Power Master, grab its Boolean state. If that is true, then we have turned the button on. So that means we want to do the first condition. If we want to turn it off, we're doing the second condition. Okay, so what are we doing when we're turning it on? To turn on the displays, we need to trigger that power on trigger that we have outgoing and wired into our user components. That is this guy here, our power on. Now, for triggers, you don't even need to set them to something. You don't need to say, hey, set it to have a Boolean that's true or set it to a value of 1. You don't even need to do that. You just need to trigger it because that's all that a trigger is. It's just a thing that happens. So grab your trigger control, snap it right, snap in the right place, snap it right in there when the button is on. You see I've got a ghost block here. I could replace that if I wanted to by grabbing the actual control to make it easier to copy and change later on. So we're turning the power on, and we want to update the label. Okay, here is one of those new blocks I was going to tell you about, the legend block. We're going to change the label of our Power Master control. So go to Power Master. Find the one near the middle that says Set Controls Visual Legend to, and then we got a string block. It's asking for some sort of text field. So we'll slide this on in here. We're going to set the controls legend to, I'll grab a real string block to make it for real, something that describes, and they can't get it wrong. I'm going to tell them displays are on, tap to turn off, right? Now they've got a button that tells them both the state of the displays in the room and what will happen when they press that button. Boom, confusion is gone. I love it. While we're here, we've always gotten into the habit of making sure that we're kind of resetting everything whenever the activity happens, even though the act of pressing the power button will clearly turn the power button on. We do know there are other things later on that will also turn the displays on, right? We've already said that when we connect an HDMI cable, we want that to turn the displays on. So if that's true, we want this button to always be on when the displays are on. So let's just cover our bases and make sure that we are setting the Power Master's Boolean to true as well, okay? May seem like a little redundant right now. It'll obviously make sense when we expand this script, that no matter what, we want to make sure that button is on when it's on. That's pretty obvious. Okay, same thing for the opposite side of things. When the button is off, we're going to do all these things in reverse. So we're going to trigger the power off control. We're going to set the legend to say, hey, the displays are off, tap to turn on. And then we're going to set the master power button to false. Voila. Okay, so far so good. It's a power button. It's not that complicated. It's a power button. Turns things on and off, right? Well, I've already said a couple times. If you're gonna do something twice, you do it big.
Sorry.
I don't know why we invited Patrick to this. I'm not entirely sure.
Is it debug?
Nope. I mean, it's a good idea to debug. That's always a good idea.
Ghost blockers.
Ghost blockers. If you're gonna do something twice, ghost blockers. That's the end of the video. If you're gonna do something twice, make it a function, right? Make it a function. We know we're going to do this twice. We know that all this happens when the power button is pressed. We know that all this is gonna happen when we plug in the HDMI cable. Two different things, gonna do the same thing, make it a function. So even though I just built out this whole event handler, let's just rip everything out of this event handler and make it a function instead. So I'm gonna make a new function. We're gonna define this function, and we're gonna say that this function is the display power, right? And we're gonna take everything from our function, we're gonna slap it down in here, and then when the power master changes, we are going to recall that function. That's our goal. But wait, that doesn't work, does it? That's not gonna work for the HDMI cable, because within the context of this function, we're analyzing the power button. So in this case, if we try to make the HDMI cable connection run this function, it's gonna end up looking at the power button. And the power button is gonna be off. So it's not gonna do the things we need it to do. So how can we leverage functions to be triggered from two different possible stimuli and still end up with the same results? The answer is we need something about the initial stimuli to carry forward into the function itself. Now, we could do this with variables. We kind of did that previously, right? With the button that was pressed. We had something remember what it was, and that survived getting into the function. There's another way we can do it. It still is technically a variable, but it's going to be a little bit slicker, and that's an argument. An argument. So this is an argument. Patrick, your shirt is terrible.
That's incorrect. My shirt is awesome.
That was a very friendly argument. I wanted you to get mad with me. You had a civil discussion.
Ask me again.
Your shirt is terrible.
Make it a function.
I try so hard. So an argument is a way. It's another name for an input into a function input. You may have noticed that there is a cog icon here in the function. If you click on the cog icon, we can add an input to the function itself. Drag an input into your function block and then close it. Right now, the name of that input, or the name of the argument, those are interchangeable terms here, is just x. That's just a standby. It's a variable. And this is a variable. It's a variable that will be defined the moment you recall the function. And then that variable gets carried along into the function to be used within the context of that function as a local variable. So let's name this argument. We'll call it the input state, because in this case, we want to define whether or not we're turning the displays on or off. So we'll call it input state. And then inside the function, we no longer actually want to look at the power master's Boolean. We want to look at the input state. We want to look at whatever this particular function has been recalled with. And if I hover my mouse over the input state, I can grab it out of there. Just pull it out of our function, and I'm going to replace power master Boolean right there. Now, rather than looking at the button, it's looking at whatever variable it's coming along with. And when I run the function, you can see currently this function is grayed out. It's not complete. It needs something. It needs information to carry along with it. What is it that we want to carry along? In this case, because we're looking at the stimulus of the power button being pressed, we're going to pass forward the power button state. So we'll grab that power master Boolean and pass that forward. This is exactly as functional as it was previously. We are looking at the power master Boolean, whether it's true or false. And down here, we happen to still be looking at the power master Boolean, whether it's true or false, because that is the information that has been passed through via the argument. What it's going to mean for us is we can now be nimble and agile with this function, because now we can recall this function from our HDMI connected state and pass the HDMI connected as a variable and run this same function looking at that instead. That is just chef's kiss world right there. That's part of hopefully what you're seeing is the agility of these writing script and block control. You can get this really quick acting nimbleness, nimbilical cord attached to all of your blocks. That's right. That's the right word.
Gross.
I'm pretty sure I nailed that. That's anatomy. I majored in anatomy and coding.
World.
It was a combined major.
Gross.
It was an online school that I am also the dean of. Okay, so let's continue this thought, because now we've added one argument, let's actually even go further with it. You may have noticed I didn't add any debug into this yet. How many times have I said debug along the way? Well, now that we've got a more complicated function, I actually want a more complicated debug. I actually want the debug to represent possible different states. If I just add one debug into my function that says, hey, the TV's on, that doesn't tell me why. It doesn't tell me how we got that information coming in. So I actually want to know what the display was set to and why, whether it's because the power button was pressed or because the HDMI cable was connected. So in order to do that, we're going to create a debug. I'm going to make a debug right here with my system, debug print. We'll move this to the bottom of our function. We do want it down here. But rather than just input a single string, I am going to concatenate strings. There's a new verb, if you've never heard it before, concatenate, to smash together two things and make them one.
Kind of like you and me, Nate.
That is only if like we both walk into the pod in The Fly and we come out as some terrible monstrosity.
It was a good movie.
It was a good movie. You'll find the Fly Pod, which we're now going to call it. Who directed The Fly? Cronenberg?
Yes.
We're going to grab the Cronenberg block, which is right here. Here's your Cronenberg concatenation block. This is going to create a string that basically takes two other string inputs and connects them. You can hit the cog icon, and you can add as many items to this as you want. So every single thing that you plug in will all get turned into one master abomination. So what do we want to say? We want to say, hey, the TV was turned on and because of this. So I'm going to say the first string is the displays are in the state of, and then we're going to input the input states, right? This is the word true or it's the word false. They're in the state of true or in the state of false. That's going to, maybe I say the displays power are, maybe that's a better use of this. Displays power are true, or the displays power are false. That'll get us there. That's perfect. That gets us halfway there. We're using this variable that came in, slapping it into our concatenation string to get a better debug. Let's go a little bit further and add the reason for it. So I'm going to actually add another argument to our function. Let's click on that cog icon again, drag in another input. This secondary input shows up on the list as at the right. Is another X. This time, I'm going to be passing in a reason, a text string. We're going to call this the reason. Okay. You can see already that up here, when we recall the function, it's asking for another input already. Let's feed it a reason. I'm going to give it a string. That string is going to say the button was pressed. I'm going to say the power button was pressed. How about that? So is this still a variable? Yes. Is it a variable in the way that we were bringing in a true or false earlier? Not quite. This time we're just bringing in a chunk of text. And this second chunk of text, we're going to append to our string down here, our debug print. I'm going to add a third and a fourth item. We're going to say the display powers are on because, why? Because reason. That's actually my reasoning for most things in the world. Why'd you do that? Because reasons. You don't have to worry about it. Because reasons. So what's happening? This debug window is going to report that the display's power are in a certain state because of whatever information we passed into the argument as we recalled that function. Let's see if it works. I'm going to save my changes. I'm going to look at my UCI. Let me split the screen here so I can see my debug window at the same time. Pop into emulation mode, so I've actually got a debug window in the first place. Okay, I go to the Displays tab. I hit the Displays Power button, and look at that. It tells me the Displays Power are true because the power button was pressed. Okay, when it concatenates, it's not adding any spaces for you. Let's do that ourselves. Let's look at our concatenation Cronenberg abomination block. I'm going to add a space before the word because and after the word because. And that way,
Can we add one more concatenated item that says love, comma, brindlefly?
Brindlefly? What is Brindlefly?
Isn't that the name of the guy from The Fly?
Oh, is that him?
Yeah.
I thought that was a character from Teenage Mutant Ninja Turtles for a second. I forget who I'm thinking of.
Don't do either of those.
Okay. So now when I click on it, boom, I turn it off. It says the displays power are false because the power button was pressed. What a lovely little sentence. And you don't know that it was hodgepodge together by Brindlefly, do you? It just happened because we built that with our debug print. And by the way, the rest of our script works too. Over here, it says the displays are off, tap to turn on. That's very clear to the user. They know what that means. I click the button and the legend has changed. Displays are on, tap to turn off. Here in our debug window, it reports all that information. This is looking real slick. This is looking real good so far. You all caught up? Test yours, make sure it's there, make sure it's functional. We got a little bit more ways to go on this because we want to make sure that we have the proper thing happening when the people plug in their HDMI connections, right? That's our next step.